Hello and welcome to this second lesson on defining a locus. We're going to carry on from where we left off last lesson, so we're still going to be looking at interpreting loci problems, drawing simple loci, and some different ones from the ones that we looked at last time, and then applying those learned skills to solve real life problems. So firstly, we're going to look at the situation where the locus of a point moves so that it remains equidistant from a fixed line AB. So we're given this line AB and we want to show the path of points that is a fixed distance away from this line. So not from just one point, but from the line in total. Now if, for instance, I wanted to show a path of points, a locus of a point, which was 3 centimeters away from the line AB, then I might start by drawing a perpendicular line down here, or measuring a perpendicular distance of 3 centimeters from point A, doing the same at point B, and then drawing a line between the two to draw a line that's parallel, because all of those points on that parallel line here would be 3 centimeters away from AB. But is there another place that would also represent a distance of 3 centimeters away from AB? Yeah, that's right, we could draw a line which is parallel above AB. But would those two parallel lines be enough? Have we missed something off? Well, actually, we do need to think about what distances are 3 centimeters away from the end points of the line AB. And if we started to map all of those points by using dots, there's our parallel line. But what we have around the end of B and also around the end of A is a semicircle of radius 3 centimeters, because when we get to A, if you imagine a piece of string that was 3 centimeters long and you start to turn it fixed at point A, what you end up with is a semicircle that goes all the way around point A, and you would have exactly the same at point B. You can map those points, and what we're left with is kind of this sort of running or cycling track kind of shape around the line. So we end up with two lines which are parallel to AB, and then two semicircular ends which have the same radius as each other. So what I'd like you to do now is to pause the video and draw the locus of a point that remains 4 centimeters from this line AB. Okay, let's see how you've got on. So hopefully you've measured a distance which is 4 centimeters from A, above and below the line, and 4 centimeters from B, above and below the line, using your ruler. And then if you join those two up, what you will end up with is two parallel lines. All we now need to do is to complete it by doing the ends. So we're going to place our compass on at B and draw a semicircle around B of radius 4 centimeters, and then do the same at A. So that completes our shape. Hopefully you've been able to do that. If you haven't, you can do that now. Pause the video and put in your correction. Okay, let's pause the video again and now have a go at these questions. Okay, going through these answers then. In the first question, in question 4a, the locus is always 3 meters away from the line AB. So draw your line AB. It doesn't actually specify how long, so you can decide, and then what you have to do is to draw a locus showing points which are 3 meters away. Now the scale that we're given is 1 meter is equal to 1 centimeter, so that means you're going to need to draw a locus which is 3 centimeters away from your line AB. So two parallel lines, one above and one below, and then two semicircles of radius 3 centimeters at either end. Very similar question in question 2, except this time the distance is going to be 2.5 meters, so therefore 2.5 centimeters. And then in question C we have 4 meters, so therefore a 4 centimeter loci around the line EF. The problem solving question says this: a new athletics track is being built and a camera run, C to R, will run in the middle of the track. The athletics track must run 8 meters around the camera run. So what we have here is a distance of 8 meters all the way around the camera run. That should say 8 meters. So 1 centimetre is equal to 2 metres on our diagram, which means that we're going to need to draw a loci which is 4 centimetres around this camera run. Hopefully you've been able to do that. Okay, let's have a look at another problem. We're now going to look at the locus of a point that moves so that it remains equidistant from 2 fixed lines as shown. So we have a line here A to C and a line here A to B, and I want a line which is always an equal distance from those 2 lines. So can you see what we're going to need to do? That's right, we're going to need to bisect this angle. We're going to need to cut it in half. So what we do is the following. We're going to draw the locus of those points that remain equidistant from AC and AB. So we get our compass, we place it on at point A, and we're going to draw an arc which goes over both of the lines AC and AB. We're going to draw an arc. It doesn't matter too much how far that arc goes along the line, as long as you keep it the same distance as you cross over both lines. So you're now going to lift up your compass and place it on the point where you've crossed, where you've intersected line AC, and you're going to draw another arc. You're then going to lift your compass off, place the point here, and you're going to draw another arc. And it's really important that you keep the compass set the same distance as you do that. So the compasses go on and we draw 2 arcs that cross. And now all we need to do is to finish our construction by taking our ruler and drawing a straight line from point A through where our 2 curves have intersected. Now any point on this line is equidistant, it's an equal distance from this line AC and this line AB. Okay, what I'd like you to do now is to pause the video and have a go at these 3 problems. Okay, hopefully you've been able to do that. One quick way of checking your answers is if we've been successful in bisecting this angle of 60 degrees that you've drawn, then obviously the line that goes through the middle should create 2 30-degree angles. So you can use your protractor to measure that now to check the accuracy of your drawing. And the same in question B, we had a 110-degree angle. That should be 2 angles of 55 degrees that you've drawn. Okay, let's have a look at another problem. The locus of a point on a slipping ladder. Let's imagine that Mr. Rhodes wants to do a bit of window cleaning and he puts his ladder up against the side of this house. There he is, he's at the top of the ladder. Now what we can see is that there is a point on the ladder which is maybe say a metre or 2 off the top of the ladder. And what we're really interested in this question is what's the locus of the point as the ladder slips down the wall. So basically this point here, which is a metre from the end of the ladder, what would happen to it as this ladder slips down the wall? What we're going to do is we're going to map that out now to show you what might be happening. So do we think that that point will actually create a curve like this as it slips down the wall? Will it be a straight line or will it be a curve like this? Let's have a little look at the problem. So the ladder slips, oh sorry Mr. Rhodes, and what happens is that ladder starts to drop all the way down to the floor. So what's going to happen with that fixed point as that ladder goes down? Pause the video, choose one of those 3 answers. Okay, let's see which one you've picked and see if you were right. So as that point moves down, we start to create this path of points. So every time the ladder moves down, one of the things that you can see is actually that point is getting slightly further away from the wall. And that makes sense because the angle at the top is changing and it's pushing that point further and further out away from the wall. So actually the correct option here is point C. You would get this curved shape. It may, as it said in our notes here, the diagram here is probably slightly exaggerated, but you would certainly get a curve going away from the wall. Okay, we're going to look at a couple of complex problems just to finish. So Katie rolls a ball from the corner of the room C. She wants the ball to remain equidistant from the two walls, so show the direction she must roll it. So again, pause the video and have a go. Okay, hopefully you recognised that this was an angle bisector problem, so we should have drawn a curve which overlapped both lines. We then need to move our compass onto this point here and this point here and draw two further curves that overlap, and then draw a straight line between the two. And assuming this was a 90-degree angle to begin with, we should now have two 45-degree angles, and this line shows the path that Katie should roll the ball. Here's a second question, so pause the video and have a go. So here a guard is patrolling an exhibit in a museum. In order to protect the exhibit, he must stay 2 meters away at all times and show the area the guard must patrol. So there's the exhibit. It looks to be like a long line, a long thin item, whatever that might be. And now what we're going to do is we're going to use the scale of 1 centimeter to 1 meter to represent our locus around this. So we know that he must stay 2 meters away at all times. We're going to need to draw a 2 centimeter locus around this line. So parallel line on the top, parallel line underneath, and then 2 semicircles at either end. Okay, thank you for listening. Now we need you to complete all the remaining Hegarty tasks set out on the guidance sheet, and you can also use the purposeful practice questions as additional work to support your learning if you want some more practice on loci. Thank you very much, and we'll see you again soon.